Hey everyone, in today's video we're going to look at communicating ideas for the second year revision. So most typically we'll be on paper 2, the hour and a half paper, but it may crop up a little bit on paper 1. So a lot of it will be sort of common sense of what you think, like we've already seen before, but it's worth just pointing out because these questions do pop up, and it's just making sure that obviously there are certain styles, certain drawings, certain techniques that are used in certain situations. So just making sure you know the differences of when they should be used, when shouldn't they be used. So first thing we'll look at is design reports. So this, you will not have done this in school or college yet. This is something very much an industry standard type of thing. So this is a record of a project that is left after the project is finished. So if you imagine the project you're doing now, if you were doing this in industry, and you would have to do it at university as well, is once a product is completely done, you would write a design report on it, and then that will get filed away so that for future reference later in the company or for whoever, if they want to go back and look at what the train of thought was, what resources you used, what the possible design ideas were from. So essentially it's kind of like the design folder you're doing now, but in a more formal academic way. So there are 3 sections to it. So this starts with an executive summary that basically summarises the whole design up, the features to it, what it does, why we've done it that way, what the thought processes were to it. Section 2 is the introduction. So it basically explains the design brief, the client, the problem you came across, how did you solve it, that kind of thing. So this is, like I say, you're planning out going, right, this is what the project we did was, and here's how we went about going through it. Then section 3 is known as the conclusion. It explains the chosen designs, any problems they face and how they were overcome, compares the selected designs compared to the specification and how it can be improved. Now that obviously is something you do quite a lot, and you will be doing in your design section, your evaluation sections. Designers may also have to write up and test up any testing they did during their project as well. So from that, it's fairly similar to the sort of folder you're doing at A level, but again, it's a more academic a document that way, but you're still going through the whole day. You're still saying this is the product we came up, and then the rest of the folder is showing how you came up to what you did. So explaining what the problem the client was, what the whole issue you're trying to solve is, and then here are the designs, here's our thought process, and basically you're justifying how you came up with what your final product was that you said in section 1. Okay, so you're justifying and explaining that this is all of this project, and we end up making this product to sell it in industry. This is the one, we're confident this is the one we're going to make the money from, and this whole document will just show you why that is. So, graphs, tables and charts. Hopefully a lot of these have been seen in maths before. Some of them are very, very simple. Some of them take a little bit more reading, but not a lot. A lot of it is basically just how do you show data and how can you read data from it. It's just important. Some of these will come up in your exams, particularly obviously in the maths content, especially if you come across an anthropometric data question, which are popular in some of the exams. So they may show you things like the data tables, but simply for you got like bar charts that just show you what the thing is, how many people, and it's a really easy, quick way to see how many people or whatever the thing is that you're trying to show. You got pictographs. Again, really easy, probably quite primary schooly, but it's this thing there just to show you some data. Really easy to understand, but there's no accurate. You're not really getting any accurate data from that. So line graphs. So these shows data changes over time. Sales of a product, for example, how popular something is. I get a line graph every time I do all your marketing for your coursework, and it can show me where you were to where you are, and I can see over time who's getting better, who's getting worse, who's staying where they are. So that's a very useful one, particularly if you are into the analysis of information, and also if you say you go into engineering and you're changing little bits here and there to try and see like certain changes and see what changes have made positive improvements, what changes have made negative improvements. Again, talk about bar charts, really simple to use. It's important to note bar graphs have the gaps, which you see over here. Histograms, very, very similar. There is no graphs. So they're usually shown a range of distribution of data. So again, this is very popular for things like anthropometric data. And then you got bar charts, again, nice and simple, but not massively, always normally done in percentages normally, not massively accurate. Then data tables, very useful things like anthropometric data, cutting lists, which you'll have to do when you make your actual physical product as well. So typically, the most common ones that will come up in your exams probably are histograms and data tables, but it's just important to make sure you can understand what the others are and how they're used and what the benefits are. The most accurate ones really that you can have. Data tables, line graphs, histograms are most accurate ones. Most common ones to come up probably will be histograms and data tables. So freehand sketching, really simple. Everyone knows how to freehand sketch at this point. We've done loads of different kinds. They could be isometric, it could be oblique, anything like that. These are nice, really quick, easy sketches to do with like your initial designs, initial sketch ideas. It's nice and easy to get ideas down because you don't need anything else. You just need a pencil or a pen and a piece of paper, and you can quickly just get ideas down. You got digital photography, so usually used for graphic design. So anyone that's doing graphic design at A level currently, where freehand drawing would not show the design, and so you're not going to be able to do anything like that neatly freehand unless you are a proper artist. Most commonly used for things like billboards, film posters, in magazine posters, those sorts of things. Cut and paste techniques. So these are typically known as mood boards, which we've done before in your coursework. So this is where you just get loads of like images to help inspire whatever it is you're doing, whether it's colour themes, shape themes, materials, techniques, whatever it may be. 3D modelling. So use when a drawing would be difficult to show features of a design. You can use a variety of different materials. So obviously things like cardboard, cards, styrofoam, HIPs, PLA if you're 3D printing. So 3D modelling is massively helpful, and obviously you will do quite a lot of that at A level anyway. Isometric drawing. So we've covered this. So the idea being that everything's at 30 degrees, everything is cut from the corner and going outwards, and use the grid paper to do it. Once you're comfortable, you can remove the grid paper. Oblique drawing, similar to isometric drawing, except that the showed from the face onwards, so rather than the edge. So if you see isometric, you see the edge is the beginning at the front. Oblique is the face. So it still shows 3 edges to it. This is very much like, if we're going to grade it, I would say this is oblique drawing. Typically is primary school level 3D drawing. That's typically the first way you learn how to draw 3D, and then as you get better, you go off into isometric drawing. Perspective drawing. So you got 1 or 2 point perspective most commonly, where you have your corners, you have your horizon, and everything goes back to the vanishing point. So we did have a go at doing this, so you could do things above and below the horizon, so you can see above the shape or below the shape. Orthographic drawing, also sometimes known as working drawing. So this is absolutely crucial, especially A level and beyond. If you go to university, you do engineering, this kind of thing. Obviously this is quite a simple shape, and it's showing a children's toy train. And we have covered orthographic drawing before, but it's very clear because everything's 2D in 2D, and this is why it's so important to do CAD work, because most CAD software, particularly Fusion, will do the orthographic drawing automatically for you. And this is basically the drawing that have all the key measurements, everything will be in line, and it's really easy to see all these key details ready for manufacturing. Exploded drawing, again, very, very useful, and again, it's something Fusion can do for you once you know how. Lets you show all the parts in this side of it, so things like screws, bolts, ribs, bushings, any other extra features you might find on the inside that will somehow be hidden. Typically, most commonly, you probably see that on things like IKEA furniture that you've got to assemble and that kind of thing. And you notice that everything is in line the way it should be, so it should all fold back together again. CAD drawings. Now, obviously, we've got loads of different CAD softwares that exist in the world. The ones in college we use are Fusion 360 and 2D Design. Some are better than others. A lot of people like SketchUp. SketchUp really is like GCSE level. As you move further up, you get more confident with it. The good ones, I know some people like to use SolidWorks or Creo. A lot of it is down to preference. Some software is better than others because of certain features that it has. We use Fusion 360 in college. I think it is the greatest piece of software of all time. Like I said before, it will do your orthographic and your exploded drawing for you. I know some people try and shy away from CAD, but really, if you're going into a design industry or university, especially now, CAD is going to be used a lot. So there's a reason why it's there. It also lets you you can put materials on there, you can do rendering where you put it into an environment so you can see how it looks. All that makes it better, so when you go to a client or you test something, it's there, it's ready, you can see how it will all look. And then annotations. Again, we all know what annotations are, but it's just making sure the whole reason you have annotations there is just because you've sketched something and you know what you're doing, you may then send your sketch off to someone that's in a different department or a different building or a different city, and they weren't there when you did it. You're not there to talk over their shoulder to explain your thought process. So these annotations are all there to explain all the key information that's in your head that you need to explain to the person. Obviously, it needs to be relevant. You can't just say, like, oh, yeah, my favourite colour is blue, I like pizza. But it would be stuff that, like key materials, any key features to the design, tips like any parts of manufacturing, any key areas that need to be like really noted, that sort of thing. Okay, so now we're going to have a look at some questions, how to apply them, so you can see what I'm on about when I say about sometimes they pop up and you need to understand what the differences are and why they matter. So first one, so figure 1 and 2 show two different design communication techniques. Discuss why a designer might use each technique to communicate information. Figure 1, exploded drawing, and section 2, sectional view of a product. So there are 6 marks, so 3 points with an explanation for each type of drawing. So pause the video, give yourself 6 minutes, and then we'll go through it. Okay, so we'll go with exploded first, which is the one on the left, which shows all the parts separated, like exploded out, hence the name exploded view. So designers may use exploded views to produce assembly instruction booklets for flat pack furniture, so think like IKEA, that kind of thing. Exploded views may allow the viewer to see all components with the product clearly. Exploded views can be used on assembly lines to assist during production. Exploded views may be used to communicate information on internal assemblies for a client. Using CAD software allows the designer to create an exploded view on the screen and reassemble the product virtually when working with the client, so you can see everything nice and easily. Hence why when you get you to use Fusion, you can like make all the components, you can make something come apart and see it all go together nice and easily. Exploded views allow consumers to identify any order replacement part, so if you know there is an internal part that is broken and you know it needs to be replaced, you know you can take it apart, you can identify the part, you can say, right, we need part 6 again, and you make another 6. So next we'll go on sectional view, which is the one here. It has all the shaded sections into it. So sectional views allow the viewer to see internal and hidden details within an assembly. So it's worth pointing out that that is different to exploded. So obviously exploded, you see all the parts separate and it will all slot together and how it will go. Sectional view is essentially if you took a product and just cut it in half. It's like with a really sharp knife and you showed all the internal parts. So you might see little areas that you wouldn't see because it's like in the middle of a casing, you might see a dent or something like that. You might see a hole where something should fit through, but you can't see it through the casing. So if you imagine you cut the casing in half and then you can see it that way. Using 2D sectional views allow dimensions of hidden components to be added onto engineering drawings, which is why they're always on those engineering drawings. So you can, like I say, you can see, obviously if this was just the outside, you wouldn't see little sections like that, but obviously you'd have the normal drawing from the outside and then you do a sectional view next to it and you say, look, on the inside of here there is this little indentation that goes in by 5mm or whatever it is. Sectional views allow designers to visualize the interaction between separate hidden components. So again, I apologise for flipping backwards and forwards, just so I can explain a bit more detail. Obviously on exploded you can see which parts and you can see that all they all slot together like that, but what you might not see there, so you can't see, for example, the screw, you can't then see the hole and where that relates to the rest of the bottom and how deep that hole is and where that is located compared to the other hole or where that's compared to other internal components. So that's why it's important to have their separate styles of drawing. So next question. Designers use a variety of techniques to generate and develop design ideas to communicate the method of manufacture of a product. Using specific examples, explain when and why a designer made use of 4 of the following: freehand isometric, flowcharts, orthographic projection, CAD, prototypes, and mood board. So total 28 marks. Now we all know how to break these down by this point. So 28 marks is 14 points with evidence. So you need to talk about 4 of the methods. 28 divided by 4 is 7 marks for each method. So realistically, for each one, you need to write 3 or 4 points for each. So pick whichever 4 you think you could write enough about. And then really, you only need like 3 or 4 points for each one with an explanation to go with it as well. So pause the video, give yourself 28 minutes, have a go going through it, and I'll go for the answers with you. Okay, so I won't go through all of them because there's a lot and it'll take a long time to go through it, but I'll go through a few little key ones that I've taken from the mark scheme. So examples should be specific as required to provide the detail of both when and why they're used. So first thing is making sure you talk about a given product and say why it would be used. It says right there, use specific examples. So then obviously It always tells you in the question what it wants you to do. If you don't give specific examples, you're not going to get those marks. So it needs to be a specific example, and then why has that drawing been used in that specific example. Better candidates will hopefully provide actual examples of the method where feasible, easier freehand sketching. So use when generating initial ideas, exploring concepts, quick to produce, little equipment, because you can just have paper, pencil, pen, whatever it may be. In planning or to guide, show procedures to work through, scheduling to provide structure and organisation. In communication with or to manufacture, work in drawing to convey details necessary for manufacture, key dimensions, materials, internal workings, anything like that. In development or modification of design, experimenting with change, easy to edit designs, links to CAM, provides accuracy, easy to share with other people, anything like that. Prior to production, to aid selection of designs through physical testing, save costs of changes once manufacturing setup is in place, to show client user evaluations, or prior to idea generation in establishing target market, style, focus, to create images, inspire, suggest colour, fashion, style. So there's loads of different examples that you could have depending on what you've gone for. If I was going to do it personally, the 4 I would choose, I would do freehand sketching, orthographic, projection, CAD, and prototypes. Those are the 4 that I would choose. So obviously isometric sketching, as we said before, it's perfect for generating quick ideas. You don't need a lot of, so that's one idea, quick ideas. You don't need a lot of equipment. It's really, you make sure you're not going to lose ideas, because sometimes you get an idea and you want to get it down on paper quickly before it leaves your head. You can do it that way. It's then quite easy to then take that and generate that in, say, CAD, for example. Orthographic projection, you then say, well, for that it's to make sure that you get all the key measurements in there, ready to manufacture. You can see all the key details in it. You make sure everything's going to lined up. CAD, obviously linked to CAM, as it said. Easy to edit. You can change materials. You can test things. You can change certain components to it. And then prototypes, obviously things like laser cutting, 3D printing. You can do rapid prototyping. You can get parts that you can test, handles. You can test features. You can test buttons. Anything like that. And then as long as you're making sure you're naming a product example and saying why has that been designed using isometric sketching, why has that been designed using CAD, and those sort of things. So that is the end of communication techniques. I know some of you may think that really is common sense and why are we going through that? But obviously these questions, if you're just looking at them, obviously you've done exploded drawing before, we've done sectional drawing, we've done freehand sketching, so we've done them before, but it's just making sure you understand how to attack the question, okay? Because obviously we've done this before. 20 marks is a big amount of marks. It can be quite intimidating. Granted, you're not going to get a 20 mark question in the new spec, but you might get a 14 mark. So it could be exactly the same question. And it could ask you to use 2 of the following, and that could be a question for the exam this year, for all we know. So, yeah, 20 mark might not be realistic, might be a 40 mark, and then you just do 2 instead. So if you've got any questions, please either email me or message me on Teams, and I'll get back to you.